Securing supply chain and company. So we're kind of going to go over what the supply chain is, why it matters, some attacks against it, how do these attacks happen, and then we're going to talk about SLSA, so supply chain levels for software artifacts. It's a model developed by Google on how to help secure your supply chain. So really, first and foremost, what is a supply chain? And it really is anything and everything that goes into your code, anything that affects your code, all the way until you release it. So that means everything from code, binaries, open source software, internal packages, any build scripts you have, packaging scripts, whatever that infrastructure the application runs on, the build runs on, pretty much everything. Additionally, and some of the things that are typically, I don't want to say forgotten, but maybe less apparent are things like who wrote the software, who reviewed the software, any licensing issues, supported versions of the software, when it was contributed, when was the last update, software that you use to check for known security issues. So you know that paper, well, some of you may know the paper, it was Ken Thompson's effectively trusting a compiler. How do you know that the software that you compiled is actually secure? Well, you have to trust your compiler at some level. I mean, the software that checks for known security issues, you either have to trust it's doing its job, or you have to make sure that that's also secure.
Like on trusting trust or something like that.
Yeah, on trusting trust. That's exactly. I haven't read that paper in years.
I know the Ken Thompson.
Yeah, it's tough, right? It's like there's a level of trust and there's a level of validation you have to do. And at the end of the day, you still may have security issues. So really, where can a supply chain be attacked? And it really comes down to internal components and external components. So open source software would be an external component. A component under a company's control would be like internal packages, maybe their build platform, and things of that sort. So different types of attacks that can be used. Dependency confusion, so you can target open source components or internal packages. We'll talk a little bit about that. I'll go through an example. Typo squatting, which is just pretty much what it sounds like. Effectively, you are preying on someone's nature of making a typo. Developer accidents, so developers accidentally release things all the time that they don't intend to through things like Stack Overflow. Maybe they're mentioning something to one of their friends and their friend says something to me, and well, that's a crappy day for the developer at that point, but that's okay. Compromising an employee's account or otherwise injecting code into the company's private repository. That can happen through any number of things. Could be an insider threat, so a malicious developer doing it. As stated, I could compromise the employee's account and then commit things on their behalf. Stealing code signing certificates and then signing things at that point and then releasing them. Makes it look like the software came from the company that really didn't come from. That's going to violate user trust. You can attack the build environment directly. You can also do ransomware. So recent newsworthy attacks. So our evil is the first one we'll talk about, and it's a ransomware type attack. So, bear with me just one moment. My presenter view went away. Oh, and now it really wants to, oh, there we go. Okay, apologies for that. I don't have all the technical details memorized and I'm only 2 copies into my day, so apologies for that. So our evil, it happened against Kaseya. So Kaseya is an MSP, so a managed service provider. So effectively they do remote management for a lot of different smaller companies. And what happened was this malware got inserted into the company through an authentication bypass, and VSA is one of their products that they use. And they ended up using SQL injection after that to upload the payload and deploy the malicious update. So really what our evil was, or how it started out, was ransomware as a service. Nice name. But then it went into creating this really, really, really good encryption malware that just did nasty things. So what happened really was during that SQL injection, they deployed this agent.crt file, and all that agent.crt file was really an encoded agent.exe file, but it was encoded as an agent.cert file, so it would get through without a blob issue. So from there, that cert file was deployed, and then that was sent to the BSA agents running on all the managed devices. From there, the SQL injection executed a PowerShell command that decoded the file and generated the exe at that point. And that exe then dropped 2 different files into the C Windows directory. The 2 files that were used was msmpeng.exe and mpsvc.dll. Now the msmpeng.exe, that is just used for Microsoft Defender. That's all that's for, or Microsoft anti-malware rather. But what they used was an older version of that. So pretty much they hooked those 2 things together, that executed, it effectively called that DLL. That DLL was very malicious, started doing a bunch of encryption. But the problem is what I mentioned previously, it deployed it to all the BSA agents running. So all of the computers from Kaseya, all of the managed service that they were doing, I think it was 1,500 companies, they had like 80,000 or something at the, or might have been even more at the time. But 1,500 companies got infected with it. All of their computers got encrypted. I think it was over 1 million computers were encrypted and completely shut down. And then REvil posted a message on their Happy blog, which is a site that they used to host. It's on Tor, so on the dark web that you can access it. And it was $70 million. That's what their ransomware was that they were asking. So pretty nasty. Why is that a supply chain attack? Well, effectively, they used Kaseya, they leveraged Kaseya's access to other companies, they got into the other companies, and they really made a crappy day for people. Trojan source. So all Trojan sources, I have an early return example. We're gonna ignore that. But all Trojan sources is you hide malicious code with Unicode characters. And typically during code reviews or that, it would be missed because it'd be encoded in a comment. Your eyes just don't look at that. Are you guys familiar with Trojan source? Okay, so let's see how lucky I am at getting. So I'm gonna stop share. Going to minimize that. Going to exit this. This is fun. I'm going to go into my VM. So effectively, all Trojan sources is, and I have a really crappy example, but all it is this right here. Now, I understand that there's a bunch of Unicode code points that you can see, and my computer just doesn't want to function. So there's a bunch of Unicode code points right here, right here, right here. So those are various RLI, so right, left inverts, right to left overrides, and stuff of that sort. And effectively what they do is when this program actually compiles, it rearranges things around. So what you would do is you would ignore what's in the comment, right? Like if that wasn't highlighted and you didn't see any U2066 or 2069, you probably wouldn't even look at it. You would assume that, oh, it's in a comment, it doesn't matter anyway. So effectively our value here is 0. Okay, so that should still be 0. That's going to print out, you're going to return 0. And it's going to call one of these functions. Now, obviously these functions look the exact same. I'll tell you this one's going to execute. This is a homoglyph of this one. So when you get down to the main function down here, it's effectively calling the one right above. But that is really what Trojan source is. So in function 1, for example, you're checking something here. Okay, it's supposed to be not work. Why is it supposed to be not work? Because this would be all rearranged. So you would look at it when you were doing a code review and it would say R value equals -1. So you would be like, oh, yeah.
So you actually have a C++ compiler that is respecting Unicode control characters?
Oh, yeah. Yeah, all this is it just during in the text editor, It just makes it look different. That's it. So during code review, you would miss it. Now GitHub and GitLab have actually included Unicode code points. They'll
But
show.
like, it's not just going to ignore the compiler. Like, I get that your text editor should display things differently.
Yeah.
But your compiler shouldn't.
Yeah, so when this actually compiles, when you actually get the executable here, this is actually, let's see if I can. I wish I could turn off all the Unicode stuff, but bear with me just 1 second while I do I wonder if I can do gedit.
Just add it if it's like going to display differently.
Oops, are you going to work? Yeah, so you can see right here that the comment here, this line right here is effectively commented, but our value here will be -1. That's what you would think it would be, but really it would, when you compile this program, this actually never executes. So in a better text editor or back in the day when this would be much more apparent, it would look like, oh, can I get it to work? No, because this is why Unicode's weird. It's not letting me do it just because it's like, there's Unicode in here, so you're trying to touch something. When you code reviewed this on a different editor, you would see R value equals -1. So you would assume that R value would return, or that in the function 1, the check something would return -1, so it would fail right here. That's what you would assume would happen. Now, I understand it looks way, way different because you're seeing the code points and my highlighting is really weird, but that's effectively what it is. So all that happens here is this line is commented out according to the compiler, so it's just ignored.
Starting to understand why the press decided to allow
Crate depression.
Identifiers, they're not allowing any control characters.
Yes. I know I'm in tech, but PowerPoint's complicated. Just a moment. From current slide. Okay. So effectively, it's just exploiting Unicode so that when someone's doing a code review, they don't notice it, so it gets through without any issues. It was a paper like 2 years ago. Places have been a lot more sensitive since then, but this type of stuff's employed, like the homoglyph, for example, when function 1 and function 1 was being called. If you have that configured so that it doesn't highlight that, I could have function 1 somewhere else in a file and you may not even see it, and you may think your function's being called when really another function's being called. So that type of stuff does happen. People just, you're not looking for those types of things. So you just don't see it. You have SolarWinds. I'm sure you're familiar with SolarWinds, right? Attacking the build system directly. So Xcode Spy, this was just targeting iOS developers directly. So effectively what happened here is there was a run script that was executed. It launches the build target, then there's a C2 server set up. It pretty much results in the download of Eggshell. Eggshell is malware. It enables spying in essence. So you gain information about someone's development process. UA parser-js. This was just an NPM library where someone took over a developer's account. The developer got hit with an email bomb. Pretty much all that means they couldn't see anything that was happening. So you just get a bunch of emails. Eventually, people just start ignoring them, and that allows someone to get into their account and it to be disguised because they're not being notified of it. After it was installed, it pretty much mined cryptocurrency. So that's how that happened. Dependency confusion's really what the name sounds like. So effectively what happens is you have an internal package and you have some other packages. So commonly in industry, you'll use an internal package management system like Artifactory or something of that sort. When you have an internal package, that will go into Artifactory, and then your open source repositories will also go into Artifactory. So this internal package management system will have all these different packages in it. So with dependency confusion, you have an internal package. What happens if I upload a package of the same name to an external or open source repository, like the Python package index, for example? Artifactory, being helpful, brings that package in. So oftentimes software tries to optimize things. So if I upload, internal package here greater than equal to 1.1.2, and I upload package version 99, that's going to get brought over into the internal package repository system. So you were expecting X, you actually got my package Y. That's what dependency confusion is. And it just happens because the software is trying to be helpful. That has happened in real life. So this kind of walks through how dependency confusion happens. You can see on the Python package index, I upload internal package 99.0.0 tar.gc. So that was actually included in the output. So one of the things that you kind of get in consultancy fashion is, well, people need the names of our internal packages and stuff like that. So this isn't really an attack vector, or we're not too concerned about it. But that's sort of the prerequisite. You have to have the internal package names. So where do you get these? You really get them from scraping GitHub. If it's a JavaScript application, you can look for requires directives, and that will tell you package names. You can look at Stack Overflow. People include them all the time without even thinking. You can guess. A lot of times, back in the day, internal package names were just the company name pre-appended to the actual package. So a lot of times companies use forks of different packages. So it's pretty easy to guess what it is and then just upload that. Here's 3 packages which are malicious. They're complete BS, but they were included in Yelp. So that happened in 2021. In fact, dependency confusion. There was a security researcher who took over 700 companies by just uploading a bunch of random package names based off what they had found through some reconnaissance. So companies like Tesla, Netflix, Apple, all were hacked with it. Now, it was just a proof of concept. It didn't actually, there was no malicious intent or anything of that sort. So why does that happen? For example, it's really it's developer assumptions, confusion, for example, if they don't understand how something works. So the extra index URL, that's what you commonly use for pip when you're trying to also include your internal package repository system. So extra index URL doesn't actually overwrite. It instead just says, hey, also check here. So if you're using extra index URL, you're targeting both Artifactory and the Python package index. That's just simple confusion. If you did index URL, it would only target what you tell it to target at that point. As I mentioned, using Artifactory, it mixes up a lot of different things. It tries to be helpful, but it unfortunately isn't. So there's also typo squatting. I kind of already alluded to it. So typo squatting is pretty much where you spray on someone's ability or someone's predisposition rather to have typos. For instance, pip install requests. If I upload packages with requests, however you pronounce the second one, and recuss or whatever the third one is, chances are people have actually used that and included that in the requirements.txt file or have installed that. It's not uncommon for that to happen. And you can get malware into systems, and you can get things like arbitrary code execution, remote code execution, and a number of other vulnerabilities. So another one is another type of attack that happened. What? Oh, sorry.
So just make sure I have it right on the typo score. Is it essentially the dependencies equivalent of like if you accidentally typo a website name and then go to like some random website that?
So essentially that's the typo part of it. So all I'm doing is I'm uploading on like Python package index different typos of common package names. And you can do this with domain name squatting too, where people have different domains. And so you just register a bunch of domains, a bunch of random ones. You hope someone tries to do it at some point, you get data. It's effectively the same thing. So all you're doing is preying on that typo. You have 3 different packages. There are the 3 different things there. You may or may not target someone specifically with that. It may just be whoever accidentally typos it. You may be targeting someone, but oftentimes people do just have typos.
Is this one of those ones that you can leave long term? Like you just set up a bunch of typos and then just leave it for like 5 months, come back and see what happens?
So yes and no. It depends on how the developer community is. So on things like Python Package Index or Node Package Manager, you can report a malicious package or you can report packages. So a lot of times, if it's something really common that a lot of people encounter, they're going to report it, and it's going to get shut down. If it's something really odd and maybe not a lot of people are using it, so that's more where you're maybe targeting a company and you're trying to do typos on that, hoping they're going to grab one of them. It may go a long time without ever being caught. Companies will use tools like different SDA tools, software composition analysis tools to try to identify that. And there won't be any issues reported, so there won't be any vulnerabilities on those packages. So they'll return that they're clean. And the companies are going to be like, oh yeah, we're good, without looking at like, oh, there was a typo here. We actually got a different package. Does that make sense? Okay.
So
Yeah.
do package managing services not should like proactively check the packages that they're spreading, or is that just like too much work?
So, you know, I wouldn't say it's too much. Well, it would be very hard to manage every single because I mean, you have a lot of people who can upload a lot of different things. So it'd be really hard to analyze every single thing. The package managers really are just there to host things. And if someone reports it, then they take action. Otherwise, they're just there to host. They leave up to the developer community to actually identify if there's an issue. Does that make sense?
Yeah, it does. I just
It's
nice if it weren't that way, I guess, right?
Yeah, it's kind of, I mean, I don't have a better example, so I guess I'll go with this example. It's kind of like FDA and cosmetics, where they're not testing every single possible cream formulation and stuff. I can't believe I'm giving this example, but yeah, but they're not testing all of that, right? There has to be an issue, and then they take action at that point. They'll take a look at, has there been something wrong here?
There are 150,000 libraries on crates.io, which is the process package manager. The process team has the manpower to look through 115,000 libraries and verify that each and every single one of them does not have some sort of attack.
I mean, that the other side of that too is just, I mean, these can be small changes in code, right? So like, if it's like the request library, I don't know how many lines of code that is, but if I add 2 lines of malicious code in there, modify it differently, someone may not even see it, so that could also happen where they just don't know. It's easier to do this than people may think it is, and it can have some pretty nasty consequences, especially for companies when you're using like a fork of a known package, because all the functionality will be there, it will work. So a company is never probably going to think, oh, there's an issue here. It's going to be when something executes and all of a sudden there's an indicator of compromise, there's weird behavior, someone's going to say, what's going on? Like there's a problem. But otherwise, if it's working, your build pipeline is going to work fine. It's going to get deployed without issue, and there's not going to be anything. So then you get to, when you find it, get to figure out how long it's been sitting there, and that's another fun topic. It is very hard to detect this stuff. And, you can use software composition analysis tools. You can run it through like CodeQL or things like that. Different companies have different software. Like perhaps if you include it, you could run through Synopsys Black Duck, which is another SCA thing. It maintains its own database. It might flag something as, hey, we don't know what this is. It may bring someone's attention to, hey, am I using the right thing? But also there's a lot of false positives, and developer trust then goes out the window, and it's a game, right? That's what it is. But it's yeah, I've seen this stuff happen, and it's really easy to happen. Great Depression. So right here, this is just another typo spotting. There's a well-known cargo, Rust Decimal. They uploaded a malicious one called Rust, well, I guess there's a well-known one called Rust_Decimal. They uploaded one called Rust Decimal, and people used it without any issues. And the way that this worked is it looked for a GitLab CI variable, which indicated it was running in the context of a CI/CD pipeline. So from there, after that environment variable is identified, that machine is known to be part of that CI pipeline. Payload's downloaded, and then it's a C2 server, and at that point, I can hijack a host really easily. That's pretty much gold at that point. So how do you mitigate things like this? You do things like avoid using extra index URL, you use version pinning, you try to get hashes of different versions to verify if those have changed or have not changed. Things like that help to mitigate it. Here's another one, event stream. And this one's even more fun because it's a dependency of a dependency attack. So what happened here was the developer, the original author or original developer wasn't really maintaining it anymore. So a new developer comes along and is like, hey, you know what? I'm going to take care of it. I'm going to help you with it. No big deal. That developer grants access to it. The new person takes over it. And what they did at that point was they added dependency to the flat map stream. That was an injection at that point. They bumped the minor version, preying on the fact that companies are using internal package management systems that are going to grab that new version. And typically when you pin a version, you sometimes pin the major version, you don't pin the minor version. So what happened there, they got, I think they infected, it's downloaded 2 million times a week. So they infected a lot of machines with that. And after a few days, what happened was the developer removed the dependency. They bumped the major version at that point. And at this point, they had malware that was targeting Bitcoin wallets or cryptocurrency wallets. And at that point, the attackers were trying to steal your Bitcoin. And if you're investing in cryptocurrency and you have a lot of money in cryptocurrency, well, whoops. So these types of things do happen. It's it's difficult to guard against them. The best thing you can do is to adopt kind of a defense in depth posture as much as you can. Make sure you're auditing things. So different things that you can do. So there's this concept of the secure software development lifecycle. And what this is effectively trying to preload all of that, all of the possible attack vectors and prevent against them while you are doing the software development process. A lot of times incorporating that, it helps to prevent or helps to identify issues early on. Development, it costs a lot of money. If it's later, if you have an active attack, it can cost millions of dollars to shut down software for a little bit of time or shut down certain functionality that people use. So pretty much the components of a secure software development lifecycle are things like having clear security requirements defined up front, make sure that your developers know those security requirements, do threat modeling routinely, establish design requirements, use appropriate cryptographic standards, so don't use MD5, for example, keeping the inventory of all your third-party components that are used, and performing dependency analysis and SCA. So that's the software composition analysis. So you should have a list. A lot of times in large organizations, there's lots of different teams. And more often than not, each of those teams are kind of responsible for their security. So this is sort of generalizing to make it a bit better, a bit more standard, I guess. Using approved tools and versions, making sure you use appropriate compiler flags, consistently run stack analysis against the source code. Make sure you do that before compiling and releasing. Perform dynamic analysis of compiled software to make sure it does everything that's intended. And then bring people like me in to do penetration testing on the software. So for threat modeling, there's really 5 major steps that you do. You define the security requirements, you diagram it, you identify all the potential threats and all the security boundaries, you apply mitigations, and then you validate that that has been mitigated or not. So like I mentioned, doing this stuff up front while an application is still in its design phase is really cheap. It's really, really easy to edit a few words on a document or a few paragraphs on a document or a design model. It's a lot harder when code's been written, developers have been paid, etc., to go back and to fix everything. So yeah, many features are susceptible to vulnerabilities just based on the overall complexity. Authentication is super complex. There's common libraries. People sometimes do their own authentication protocols. There's RBAC, so role-based access control, making sure that you're logging things, make sure you're not logging things like access tokens, making sure you have the right cryptographic protocols. So making sure things like if you're operating in AES CBC mode, you defend against chosen ciphertext attacks. So yeah. Make sure you're running SCA tools. So I mentioned Synopsys Black Duck, I mentioned Sneak, npm audit, yarn audit, and then doing manual reviews of the package manifest. The problem with SCA tools are just, and we encounter this all the time, just because an SCA tool actually identifies that a dependency is vulnerable doesn't actually mean the application itself is vulnerable. So again, it's weigh and measure, right? Like is fixing it just a simple patch? Is it just incrementing the minor version or incrementing the major version going to the latest point release? Does it require significant overhaul of the code? If it does, maybe it's worth exploring, are you actually using the application or using that dependency in a vulnerable manner? And something, I guess, one thing to say, I've seen outputs of these tools range in the 100, 200, 300,000 different vulnerabilities identified. Now, if you update everything, you can probably get that down to maybe a few hundred. But if you give a developer 300,000 dependencies which are vulnerable, the likelihood a developer is going to go through every single one of those and identify if they're using it in a vulnerable manner or not is probably 0. Just because it would take way too long. So yeah. So, what IDEs are being used? Do you have appropriate plugins? Are you just using VS Code and a bunch of other plugins that maybe aren't trustworthy? What compiler or linker flags are being used? So are you using where, wall, Wextra, fstack protector, wsign conversion, wconversion? All of those are for GCC specifically, all of those are various compiler flags which harden the application, harden the security posture, add stack canaries, stuff of that sort. Is the source code free of secrets, including in the history? So this is one that you encounter quite a bit when you're looking at things. Is sometimes there's secrets in source control, sometimes there's secrets in test code, which also work in production code. Sometimes there are no secrets, but if you go back in history or you go back to when the application was first developed, you find them all because maybe they were committed. That type of stuff happens. Not including the not including the .env file in your git ignore. That type of stuff can lead to issues. Developer documentation being free of secrets. I've seen a lot of pictures and documentation that have all the information that you need. What stack analysis tools are being used? So there's tools like SEML, PBS Studio, SEMGREP. Are they using stack analysis tools? If they are they using them effectively? Are they triaging the results? How often are they using the stack analysis tools? And other types of areas to look at, you want to make sure the build's reproducible. You want to look at how code is being reviewed. What's the release look like? Are there release engineers? Can other people just generate releases whenever? Are build artifacts stored and retained for a sufficient period of time? So obviously you want a reproducible build. So you want to make sure all the artifacts from your builds are stored for at least 18 months, preferably in perpetuity. Is access revoked? So if you fire someone, is that access revoked right away? Is it not? A lot of times you'll see people still have access 4, 6, 8 months later. How long is a session active for a developer? Is the build automated? Is it scripted? That type of stuff's all stuff to look at. So this is SALSA, so supply chain levels for software artifacts. So you'll have to forgive me, I did some edits and 4 is the most secured. 3 is now the most secure. So my previous slides were based off the 0.1 spec. It just became 1.0 not that long ago. So prior to when it was 0.1, there were 4 components really. It was source, build, provenance, and common. They've gotten rid of those for right now and just focus on build. And within the build levels, they include provenance requirements and source requirements from there. Part of the shift for that was it was just a little bit easier to understand, a little bit easier for developers to follow, a little bit easier for companies to sort of follow this process. So 3 is the most secured. So with level 0, it just means you haven't adopted anything with SALSA. Level 1, your provenance should be showing how the package was built. Level 2 is you have assigned provenance and it's generated on a hosted build platform. And level 3 is the build platform itself has been hardened against attacks. So level 1 is really focusing on mistakes and documentation issues. Level 2 is focusing on tampering after the build. And level 3 is focusing on tampering during the build. So level 0, pretty self-explanatory. Level 1, you just want to make sure you have a consistent build process, that your build platform generates the provenance, which includes what built it, what was the build process, what were the top level inputs to the build. And you want to make sure that provenance, which is just what your software is, everything about it, is actually released to people who are using your software. So in build level 2, it's running on a hosted build platform. The provenance is signed and it's generated on the build platform. And you do verification of the provenance and you validate that the provenance is actually authentic. They have tools for this. Tools are actively being released. I think NPM has a SALSA verifier tool now. So the goal here is you're really trying to prevent tampering. and you're trying to deter adversaries and that type of stuff. Okay, and L3, the build platforms must prevent each one from influencing another one. That's actually kind of an interesting one because oftentimes you don't think of builds in isolation, but if you're generating multiple builds or multiple builds are happening within a company, occasionally they can have influences on another, and so you can leverage that to get malware into a system. We've seen that happen in the past. So you want to make sure that the builds are entirely isolated. One build can't influence another build. The results can't be influenced or anything of that sort. And this is why it's included in level 3, is level 3 you want to prevent tampering during the build process. You also want to prevent any secrets that are used to sign the provenance from ever being accessible, because obviously if you have the secrets, well, you can sign your own provenance at that point and then forge away, and then it causes issue. So at level 3, really this is strong confidence at that point that the package was actually built and it's official, it's safe. That is SALSA for right now. I know SALSA is actively being worked on and expanded more, so there's probably going to be a lot more changes in the future. My references for slides, and there's my email. So that is everything I have. Thank you very much. So sorry that was a little bit of a cluster for a bit. I'm still a little bit tired. Are there any questions or anything?
So what kind of qualifications do you look for tree or shooting cybersecurity?
Certs are good to have. They are sort of a common basis, right? So having a cert like an OSCP or something like that, it at least demonstrates a level of knowledge. Now, if you ask me, I really don't care about certs at all. I don't look at someone's, so I review every single resume. I don't look at someone's degree. I don't look at certs, but for other companies, certs can be a good entry point into getting a job. What I look for are what programming languages you know, because I'm going to ask you questions in those programming languages. I look at if you've included your GitHub, how's the activity beyond your GitHub? I'll check out your LinkedIn. Do you have an interest in cybersecurity? Because it is a fork in the road between software development and cybersecurity. I will hopefully look at so depending on your resume, I'll hopefully like to see what classes you've taken. Like if you're interested in cybersecurity, I'd like to see did you take computer security? What tools have you played around with? Maybe you have running familiarity with Burp Suite, so emphasizing that. Those are the things that I look for. When I interview you, I'm looking for your thought process. I'm looking for, do you have a demonstrated interest in cybersecurity? Because it can take years to be able to run projects on your own and stuff like that. Do you read blogs? Do you listen to Darknet Diaries? Do you listen to security, cryptography, and whatever? Can you tell me an exciting podcast that you've heard and things about it? Have you read a Frack post? So Frack is a hacker board that talks about famous hackers. And maybe you saw something really interesting. Do you ask a lot of questions during the interview? If you don't know something, are you curious as to why, or are you just like, I don't know, sorry. Those are the things that I look for. Those are all those things I can train and people can train. That means a lot more than, trying to just, I guess I should say, kind of goes without saying, but if you worked in another company or something like that, if you ever say during an interview, I probably shouldn't say this, and you continue on and you continue talking about it, it's a very big red flag during the interview process. That's an automatic rejection for me. I will automatically reject at that point, just because the nature of cybersecurity is very, very private, right? if you really shouldn't be talking about something, you really shouldn't be telling me anything about it. So if you ever catch yourself in that, just stop. Just be like, never mind, move on. That type of stuff. So I'm looking for a trainability and interest over demonstrates hard skills.
Good advice for all of us.
No, I mean yeah, that definitely. Any other questions about this or about what am I looking for or how or anything up from like Wednesday? Cool. Sweet.
Oh, I was gonna ask a question about, so you said, I think in your last talk about, some of Casa's customers being like AWS or Azure.
Microsoft, yeah.
I was interested, I'd be interested to hear what you have to say about security of cloud systems, like letting Azure or, cloud service provider handle the security on your software that you're running with them, or versus trying to do all that in-house, on your own hardware.
So,
Do they do a good job with their security, I guess?
oh yeah, absolutely. But we also consult for them, so of course. But no, they do cloud provide. So think about it from like, I guess, a business perspective, right? Lots of people use Azure, lots of people use AWS, lots of people use the Google Cloud environment. If they get hacked and there's a massive vulnerability, it's going to damage their business at some level. So these companies, all of them invest a crap ton of money into security engineers. They handle, if you report a vulnerability, they are fixing it immediately. These companies, this is their business, right? So they're hugely invested in cybersecurity. They're hugely invested. Is that necessarily better than doing your own cybersecurity or running everything in-house or whatever? That's sort of a decision. Sometimes people find that it's really easy in like cloud environments, for example, to rake up a huge amount of money and cost and stuff because maybe you're using extra resources you don't need or something of that sort. But I mean, the company's business model is based off people leveraging their software and it being protected, all your data being safe. So yeah, they're very committed to that and they're very secure. Any other questions? Yes.
Do you have any recommended cybersecurity podcasts?
Darknet Diaries is interesting if you want to hear kind of like the nefarious things that people do. Security, cryptography, whatever, is a great podcast for the more technical aspects of cybersecurity. So they'll have people talk about mutual TLS, and people talk about new software, people talk about new attack vectors or quantum resistance or aspects of linear algebra. So that's a really good podcast. I really like that podcast. But yeah, Darknet Diaries is sometimes fun just to see the nasty things people are doing. Yeah.
Sorry, what was the name of the second?
Security, cryptography, whatever. It's actually a really good podcast. I really like it. My colleague Ramsey knows that one of the hosts on, and yeah, so it's kind of really cool to be associated with that. So.
What was the site you mentioned? I get with like an app.
Oh, Frac. So Frac boards. It's not F. It's PHRACK. It messed me up when I first heard about Frac years ago. They interview hackers, so you get to see how people got started. It's more of an underground forum, so these people are more on the fun side of hacking. Guess we call it fun, but it's a really interesting forum. It's older. You see a lot of like older type attack vectors and stuff. Anything else? Yes.
Like for the summer, what are some like certifications should start? Maybe like not something that's gonna like resonate like builder, but something that can like help you learn.
honestly, Portsmouth Web Security Academy, okay, so for certs, I would say CompTIA Security. I would say OSCP, it's just a 24-hour test. You have to complete some Pen 200 level coursework to just prep for it. I think the OSCP, I forget, it's like you have to hack X number of boxes. You have 24 hours to do it. Once you start, you can't stop. Those are good certs. As far as learning skills, I would say Portsmouth Web Security Academy, it's free. You can use Burp Suite, you can get familiar with things, and I guarantee you, if you can prove that you know Burp Suite really well, a lot of people are going to be interested because that's sort of the gold software. I mean, I think it goes for like $400 a license up to $5,000. Like that's what enterprises use. So if you can prove you know it, that goes a long way.
Remember to speak with the sugar.
Yeah. So yeah, I'll like go. So it's just right here. That's what it is. It walks you through a lot of different things. So they have a lot of different labs that you can do. So here's some labs about SQL injection. Here's some labs about cross-site scripting. And you can see the rating. So, you know, CSRF. So if you can get some of these down and you can figure out how it happens, that goes a long way. And I mean, these are building blocks. You don't really see exactly the same thing in industry, but these are stepping stones. Any other questions?
Hey, we generated a lot of interest. Later.